Hello student, let us take a look at this question on belt drive. A table is given here. The question is on electric motor that drives an exhaust fan having the data in this table. The diameter of the motor pulley is 400 mm and the diameter of the fan pulley is 1600 mm. The angle of wrap of motor pulley is 2.5 radian and that of the fan pulley is 3.78 radian. The coefficient of friction on the motor pulley is 0.3 while that of fan pulley is 0.25. Then the speed of the motor pulley is 700 rpm and the power transmitted is 22.5 kilowatt. Here we are to calculate the width of 5 millimeter thick flat bed and we are to take permissible stress for the material as 2.3 megapascal. Now let us start. Solution. Let us take a look at our given. All our given here and in the table. Now we are given the diameter of the pulley as D1, which is equal to 400 mm. From there, the radius R1 will be 200 mm. Also, we are given the diameter of the fan pulley D2, which is 1600 mm, and its radius R2 will be 800 mm. Also, we are given the angle of wrap for the motor pulley θ1 to be 2.5 radian, and we are given the angle of wrap for the fan pulley θ2 to be 3.78 radian. Also, we are given the coefficient of friction on the motor pulley as 0.3 and the coefficient of friction on the fan pulley as 0.25. And again, we are given the speed of rotation of the motor pulley N1 as 700 rpm. We are also given power transmitted, which is 22.5 kilowatt, which is equal to 22.5 times 10 raised to power 3 watt. We are also given the thickness of the belt T, which is 5 mm, which is equal to 0.005 meter, and we're given the permissible stress to be 2.3 megapascal, which is equal to 2.3 times 10 raised to power 6 Newton per meter square. Now, this is what we are given. Now, let us calculate this for the motor. For motor, we have mu1 θ1, which is equal to, the mu1 is 0.3, then multiplied by 2.5, and this one gives 0.75. Then for the fan, we have mu2 θ2, which is equal to 0.25 multiplied 3.78, which is equal to 0.945. When you look at these two, you find out that that of the motor pulley is less than that of the fan pulley, and our design is going to be based on the smaller one. For that, we are going to use that of the motor pulley as the basis for our design. Then for that reason, now let us look at the tension. T1 as the tension on the tight side, and we have T2 as the tension on the slack side. Then we know that the velocity of the belt V is equal to pi d1 n1 over 60. Since we are going to use motor for our design, so we are going to use d1 and n1, which is equal to pi times our d1, which is equal to 400, which is 0.4 in meter, times our n1 is 700, divide 60, and this gives 14.7 meter per second. Power transmitted P is given by T1 minus T2 multiplied by the velocity of the belt. Then from here, let us substitute. Power is 22.5 times 10 raised to the power 3 is equal to T1 minus T2 multiplied by the velocity, which is 14.7. Then from here, we have T1 minus T2 is equal to 22.5 multiplied by 10 raised to the power 3 over 14.7, and this one gives 1530 Newton. That is T1 minus T2 is equal to 1530. Now let us call this one equation 1. Then also 2.3 log T1 over T2 is equal to mu theta. We are going to use mu1 theta 1 because that's the basis of our calculation, which is equal to 0.3 times 2.5, which is equal to 0.75. That is 2.3 log T1 over T2 is equal to 0.75. We divide both sides by 2.3. We have log T1 over T2 is equal to 0.75 divided 2.3, and this gives 0.3261. Then from here we have T1 or T2 is equal to 0.3261. Then we take antilog of both sides. When we take the antilog of log T1 over T2, it will give us T1 over T2. When we take the antilog of 0.3261, it will give us 2.12. Now we'll call this one equation 2. Now when we solving equation 1 and 2, we have our T1 to be equal to 2896 Newton, and our T2 is equal to 1366 Newton. Now let B be the width of the belt. And when you look at the velocity of the bed, which is 14.7, which is greater than 10 meter per second, therefore, we are going to consider centrifugal tension. If the velocity of the belt is less than 10 meter per second, we don't need to consider centrifugal tension. But here, we have 14.7 meter per second. For that, we are going to consider centrifugal tension in our design. Then here we have the mass of the bed per meter, mass of the belt per meter length, m is given as area of the belt multiplied by the length of the belt multiplied by the density of the belt material. That is, mass is equal to area of the belt is the width of the belt multiplied by the thickness of the belt multiplied by this length is going to be 1 meter because we are calculating mass per unit per meter length. So L is going to be 1, then multiplied by the density. Here, assuming that the belt is made of leather whose density is 1000 kilogram per meter cube. This is just an assumption. So for that, we are going to use the density of the leather belt, which is 1000 kilogram per meter cube. Then from here, we have M is equal to B times the thickness is 0.005 times 1 times 1000. Then here we have M to be equal to 5B measured in kilogram per meter. Then also we are going to consider the centrifugal tension. Centrifugal tension TC is equal to mv square, which is equal to the mass is 5b multiply 14.7 square. Then from here, when we evaluate, we are going to have 1080b measured in Newton. Then we know that the maximum tension or the total tension in the belt, maximum tension in the belt, T is equal to T1 plus Tc. And we know that this maximum tension is equal to the stress multiplied by the area. And this implies that from here, when we substitute the value of our T1, which is equal to 2896 plus our TC here, which is 1080B, then is equal to the stress is 2.3 times 10 raised to power 6 times area. We know that area is width times the thickness. So the width is B, then the thickness is 0.005. Then from here, we have 2896 plus 1080B is equal to, we will multiply this one, this will give us 11500B. Then from here, we collect the leg terms. We have 11500B minus 1080B is equal to 2896. So when we subtract 1080B from 11500B, we are going to have 10,420B, which is equal to 2896. Then we divide both sides by 10,420. B will be 2,896 divide 10,420. 420, and this will give 0.278 meter, which is approximately 280 millimeter. Thank you very much for listening.